Consider the following statements regarding the lifespan of a star. Statement 1. Most massive stars have less life when compared to least massive stars. Statement 2. The mass of the star determines how much energy to be produced and how quickly the star can do so. Which of the above statements is or are correct? Statement 1 only, statement 2 only, both the statements 1 and 2, neither 1 nor 2. Let's discuss the answer. The sun is a star. The age of the star is 4.6 billion years. The lifespan is expected to be 10 billion years as per scientific calculations. Do you know what would have happened had our sun been 1.5 times of its present mass? Simply, it would have been dead by now. To be more precise, our sun would have been dead before 1.6 billion years itself. If you observe the chart displayed here, on one side you will see the masses of stars, and the other side the lifespan of those stars. The star which is most massive or more massive, that is, let's say in this example, in this chart, you have a star with 60 solar masses, which has got a lifespan of just 3 million years, and the star with 30 solar masses has 11 million years of lifespan. And you observe that the star with 1.5 solar masses has got 3 billion years of lifespan, and our sun has the lifespan of 10 billion years. If you observe that there is a trend or there is a relation between the mass of the star and the lifespan of the star. The relation is an inverse relation. That is, one increases, the other decreases. By the way, what is mass? Mass is the amount of matter with which the object is made of. It's a substance that makes an object. That's what is called mass, nothing to do with the weight. And what is solar mass? Solar mass is roughly equal to 2 into 10 to the power of 30 kilograms. That is approximately equal to our sun's mass. So one solar mass is equal to the mass of one sun. When we say 60 solar masses, it is equal to 60 times the mass of our sun. There is a relation between mass, temperature, luminosity, and age of any star that you take. In general, a star uses 10% of the mass as fuel. So, if you have a massive star, it will have more fuel to survive. If it is less massive, that star will have less fuel. However, in reality, it is not happening so. What is the reason? The reason is the rate of burning the fuel. The rate at which the fuel is burnt is different in massive stars and less massive stars. I'll oversimplify with an analogy. In olden days, our grandparents and great-grandparents used to prepare food with firewood. So they used to have a bundle of logs. So every day they take 2 or 3 logs and put it in the stove and prepare food. So one bundle of log they used to use for about roughly for, let's assume that they used to use for 2 to 3 weeks. And if they have piled up everything in one place and suddenly, and if it catches fire, that hundreds of bundles gets burned within hours or days. Although one bundle our grandparent or our grandmother used to use it for about 2 to 3 weeks, but hundreds of bundles were burnt in no time or within a day. What's happening? It is the rate at which that firewood is being burnt. Something of this sort happens in the sun, or for that matter, for any star. Generally, what happens is, if the star is massive, it is more luminous and it has more temperature. They are all related. When it is more massive and when it has more temperature and when it is more luminous, the lifespan gets reduced. Okay, all these things are one side and the age of the star is the other side, and they have that inverse relationship. And understand that there is a slight difference between luminosity and brightness. Brightness is how a star appears to us, how we perceive a star. The luminosity is the amount of electromagnetic radiation that is emitted into the space per unit of time. In simple words, the amount of light that comes out from the star, the total amount of light that comes out of the star per unit of time into the space. The luminosity is objective. The brightness is what it appears to be. For example, if you take two stars which are of same luminosity, however, one star is very close to us and the other star is very far away from us, the star which is closer to us appears to be more bright than the star with the same luminosity which is far away from us. Although they're both luminous with the same magnitude, the brightness differs. Thank you.